Most people who dig into browser fingerprinting stop at the device layer. Canvas hashes, font lists, WebGL renderer strings, time zone mismatches. That's the part anti-detect browsers were built to handle. But underneath that, there's a second layer running the whole time, and it has nothing to do with your device and everything to do with you. It's called behavioral biometrics, and it's a bigger part of how platforms catch multi-accounting and fraud than most people testing these tools ever realize. I run proxy infrastructure, and I test anti-detect browsers against real platforms for multi-accounting work, day in, day out. The device fingerprint conversation gets covered everywhere. This one doesn't, so that's what I want to walk through here. How a site learns to recognize how you interact no matter what browser profile you're sitting behind. Device fingerprinting asks, what is this machine? Behavioral biometrics asks a completely different question. What is this person doing right now? And does it look like the last 1,000 people who did the exact same thing? It's not a snapshot taken once when a page loads. It's a continuous signal collected quietly the whole time you're on a page. Every movement and every pause feeding into a model that's building a picture of you specifically, not your hardware. Start with mouse movement since it's the one people underestimate the most. A site can watch the curve of your path between 2 points, the way you speed up and slow down around a click, the small jitter every human hand produces without meaning to, and whether you overshoot a button and correct or come in on a dead straight line. None of that needs permission from you. It's sitting right there in the standard event stream your browser already sends. Typing gets the same treatment. Dwell time is how long you hold a key down. Flight time is the gap between letting go of one key and pressing the next. And the pattern those two numbers make is stable enough per person that some banks and enterprise login systems use it as an actual authentication factor on its own, not just a side signal. You don't type like the next person, and the script definitely doesn't type like either of you. Scroll behavior adds another layer, speed, whether you move in bursts or a steady drift. How often you scroll back up because you missed something. On mobile, there's touch pressure, contact area, swipe velocity, the angle your finger hits the screen, all reported straight through the pointer events and touch events APIs. Phones also expose accelerometer and gyroscope data, which picks up the tiny involuntary movement of a hand actually holding the device, something a phone sitting flat on a farm rig doesn't produce. Stack all of that against session-level timing, how long you dwell on a page before adding something to cart, and you've got a profile that has nothing to do with your IP or your canvas hash. And to be clear, none of this needs special access. It's collected with ordinary JavaScript listeners, mouse move, key down, touch start, device emotion, the same events every browser exposes to any page that asks. Usually it's bundled into a script the site is already loading from a third-party vendor, so it's running before you've even noticed the page finished loading. I've watched this play out on our own phone farm setups, where a rack of real handsets sits flat and never gets picked up. And the difference against a customer actually holding a phone is obvious once you know to look for it. Accelerometer noise from a hand naturally trembling, a phone getting rotated slightly while someone reads a message. None of that shows up on a device bolted to a shelf. A site checking for that gap doesn't care what apps or profiles are installed. It's reading motion data the operating system exposes by default. Fox. Session replay tools like FullStory and Hotjar were built for UX research to let a product team watch how real users move through a checkout flow. But the event stream they capture to answer that question is exactly what a fraud model needs to build a behavioral fingerprint. So the same data ends up feeding both purposes whether the product team intended that or not. Dedicated fraud and bot management vendors, names like Datadome, Forter, Sift, and BioCatch, sell products built specifically around this signal, usually stacked on top of device fingerprinting and IP reputation rather than replacing either. The reason platforms lean on this layer isn't abstract. A device fingerprint can be reset, a new profile, a wiped cache, a different canvas noise seed, and the device level signal starts over from zero. The person moving the mouse doesn't get reset along with it. If the same behavioral pattern shows up across 20 accounts that are all supposedly different people, that's a far stronger signal than any single device fingerprint on its own, because it's expensive to fake and it doesn't change just because you rotated hardware identifiers. Stack enough of these signals together and the platform isn't looking at one account at a time anymore. It's building a graph. This behavioral pattern links to that one, which shares a payment method with a third, and suddenly 20 accounts that each passed their own device check individually collapse into one cluster the moment someone runs the numbers. That's the actual mechanism behind a lot of mass account actions that look sudden from the outside. It rarely happens because of one mistake, it happens because enough small signals pointed the same direction at once. A spotless device fingerprint sitting on top of a behavioral pattern that repeats across supposedly separate accounts is itself a red flag now, maybe a bigger one than either signal would raise by itself. This is the part that gets misunderstood constantly, including by people selling anti-detect tools as more complete than they actually are. Tools like multilogin, GoLogin, Chameleon, Ants Power, and Dolphin Anti all work the same basic way. They intercept and rewrite the browser APIs aside queries to build a device fingerprint, canvas output, WebGL parameters, installed fonts, the hardware concurrency value, screen resolution, time zone, and so on. That's genuinely solid engineering, and it does change what a fingerprinting script reads back when it asks those questions. But none of that touches how your mouse actually moves across the screen, because that was never the layer they were built to control. The pointer event stream a site receives comes straight from the input hardware and the actual person moving it, not from anything a browser profile tool can rewrite. A spoofed canvas hash and the real human hand are two completely separate signals arriving at the same server, and only one of them is under the anti-detect browser's control. The other one is just you, whether you meant to hand it over or not. This matters most if you're running multiple profiles through any kind of automations. Scripted mouse movement tends to leave a signature behind, paths that are too geometrically clean, uniform velocity where a real hand naturally speeds up and slows down, click timing that lines up to the millisecond in a way no person manages twice in a row, or in cruder setups, the cursor just jumps straight to a coordinate with no path recorded at all. A behavioral biometrics model doesn't need to know a thing about your browser fingerprint to catch that. It only needs to see the same statistically odd mouse signature repeating across accounts that a device fingerprint check already waved through as distinct. Fruit bots make this even easier to spot, since a lot of account creation and login flows layer in extra frictions specifically to collect this data. A CAPTCHA that's watching your mouse path before you even click it. A login form that logs how long you paused before typing your password. A two-fire prompt that notices you filled the code in from a clipboard instead of typing each digit with a normal gap between them. None of that is described anywhere as a security feature. It's quietly sitting inside forms that look completely ordinary. I'm not going to walk through how to get past any specific vendor's model here. That's out of scope for what this is. But the honest technical point stands regardless of that. No anti-detect browser I've tested markets behavioral biometrics evasion as part of what it does, and none of them can, because the signal is generated outside the browser process entirely. The closest thing to a mitigating factor is also the least exciting one, an actual different human operating each profile at a normal pace without any scripted interaction driving the mouse for them. That's not a feature of any tool on the market. It's just what happens naturally when a real person uses a browser instead of a script pretending to be one. It doesn't make an account undetectable, and it doesn't override whatever else a platform is checking. It just means the behavioral layer isn't handing them a second independent reason to link accounts that the device layer already tried to keep separate. What doesn't help, no matter what a sales page promises, is a human-like mouse movement library bolted onto an automation framework. Some of these just interpolate a Bezier curve between 2 points and call it a day. Real human movement has irregular microcorrections. It varies from session to session, and it actually correlates with what's on screen instead of just the start point and the end point. A modeled curve is still a model under the hood, And behavioral biometrics vendors train their systems specifically against synthetic movement, because it's the single most common thing they see coming through. It's also worth being straight about what anti-detect browsers are actually for. They exist to manage separate, legitimate identities and business use cases across the device fingerprint layer, an agency running several clients' ad accounts, a store operator managing storefronts across a few marketplaces, that kind of thing. None of it is a workaround for restrictions tied to fraud, stolen payment methods, or identity misuse, and behavioral biometrics is one of the specific tools platforms built to catch exactly that kind of abuse. Nothing in this video changes that, and no product in this category changes it either, whatever the marketing around it might imply. When I test the browser for the reviews, I'm checking how well it holds up against the fingerprinting checks it was actually designed to beat, consistency across a profile's canvas and WebGL output, whether the time zone and IP line up, whether the font list matches the claimed OS. That's a real measurable test with a pass or fail result behind it. Behavioral biometrics never enters that scorecard for any tool because it isn't a claim any of them are making, and I'd rather say that plainly than let a good fingerprint score imply more than it does. So here's the honest summary. Behavioral biometrics is a passive, continuous layer that profiles the person, not the device. It sits alongside the fingerprinting layer anti-detect browsers were built to manage, not underneath it, which means spoofing your canvas output, your WebGL strings, or your font list changes nothing about how your mouse moves or how your fingers hit the keys, because none of that data ever passes through code and anti-detect browser controls in the first place. Any product that claims to solve both layers in one tool is overselling what it does. Testing the fingerprint side honestly still matters. I spend most of my time doing exactly that, but it's only ever half the picture. It tests these browsers on real multi-account setups, so the written reviews and the picks I actually trust are all at antidetectbreview.org. Full written reviews and tested picks at antidetectbreview.org. Go check it out and subscribe for more of this.